The universe is full of mysteries, many of which remain invisible to the naked eye. Imagine this: over 1.5 billion hidden objects, distant galaxies, newborn stars, and ancient stellar remnants are concealed behind veils of cosmic dust just beyond our sight. For centuries, astronomers have struggled to pierce through these obscuring clouds. But now, thanks to groundbreaking infrared technology, we're finally pulling back the curtain on these celestial wonders. This revolution is led by the European Southern Observatory's ESO Visible and Infrared Survey Telescope for Astronomy VISTA, an instrument that has transformed our understanding of the Milky Way. For the first time in history, we have a comprehensive infrared map of our galaxy, cutting through the dust to reveal its hidden structures in unprecedented detail. Today, we'll explore how this 13-year survey was conducted, the astonishing discoveries it has unveiled, and what these findings mean for our understanding of the cosmos. The power of infrared astronomy: most telescopes observe the universe in visible light, the same wavelengths our eyes detect, roughly 380 to 700 nanometers. But visible light is easily blocked by cosmic dust, leaving vast regions of space hidden from view. VISTA, however, operates in the infrared spectrum 900 to 1,200 nanometers, allowing it to see through dust clouds and capture objects that would otherwise remain invisible. This includes young stars still forming inside dense nebulae, brown dwarfs, or failed stars, too dim to emit much visible light, ancient stars buried in the Milky Way's crowded central bulge. To understand the difference, compare these two images of the Lobster Nebula NGC 6357. In visible light, the nebula appears as a glowing pink cloud, its stars obscured by dust. In infrared, the dust becomes nearly transparent, revealing millions of previously hidden stars. This is just the beginning. The VVV survey, mapping the Milky Way's heart. Between 2010 and 2023, VISTA conducted the VISTA variables in the Via Lactea VVV survey, the largest infrared study of the Milky Way ever attempted. The results: 200,000 high-resolution images. 500 terabytes of data, equivalent to streaming a 4K video for 3 years straight. A map covering 8,600 full moons worth of sky. The survey focused on the Milky Way's central plane, including its nuclear bulge, a dense region of stars surrounding the supermassive black hole Sagittarius A*. Key discoveries from the VVV survey. 1. The youngest stars in the galactic bulge. Astronomers discovered 35 classical Cepheid variable stars in the bulge, stars that pulse in brightness over days or months. These stars are less than 100 million years old, some as young as 25 million years. Their presence suggests ongoing star formation in the bulge, challenging the old belief that this region was dominated by ancient stars. 2. A hidden disk of young stars. The Cepheids trace a previously unknown thin disk of young stars stretching across the galactic center. This implies that star birth has been continuous in the Milky Way for at least 100 million years. 3. Ancient relics are Lyrae stars. In 2016, VISTA spotted 12 Lyrae stars, ancient stars typically found in globular clusters near the galaxy's core. These stars may be remnants of a primordial globular cluster absorbed by the Milky Way billions of years ago. Their existence supports the theory that the galactic bulge formed through violent mergers rather than gradual gas accumulation. For new globular clusters, before VISTA, only 158 globular clusters were known in the Milky Way. The survey added 2 more: VVVCL001 and VVVCL002, the latter being the closest globular cluster to the galactic center ever found. Intriguingly, VVVCL001 might be gravitationally bound to another cluster, UKS1, potentially forming the Milky Way's first known binary globular cluster pair. 5. 96 new open star clusters. Unlike globular clusters, open clusters are younger and less dense. 1. VVVCL003 is the first open cluster discovered on the far side of the galaxy, 15,000 light-years beyond the Milky Way's center. Beyond VISTA, Gaia's galactic archaeology. While Vista reveals hidden structures, ESA's Gaia mission has been mapping the motions and positions of stars to uncover the Milky Way's violent past. Gaia's shocking findings: 30,000 stars are moving backwards compared to the rest of the galaxy. These stars are remnants of Gaia Enceladus, a dwarf galaxy the Milky Way collided with 8 to 11 billion years ago. At least 6 other galaxies have been absorbed by the Milky Way, shaping its structure. The Sagittarius dwarf galaxy has already collided with us 3 times and will merge again in the future. Gaia's mission ended in March 2025, but its final data releases coming in 2026 and 2030 will provide even deeper insights into our galaxy's evolution. Euclid, the next frontier in cosmic mapping. Launched in 2023, ESA's Euclid Space Telescope is taking the next leap in understanding the universe's dark matter and dark energy. Euclid's first images October 2024. 1. The Perseus Cluster contains 1,000+ galaxies and 100,000 background galaxies. Revealed 630 previously unknown dwarf galaxies, key to studying dark matter distribution. Point 2. Irregular galaxy NGC 6822. A low metallicity galaxy resembling early universe conditions. Euclid found new globular clusters and star-forming regions hidden in its dust. 3. Globular cluster NGC 6397. Euclid's wide field view captured faint outer stars missed by Hubble. 4. The hidden galaxy IC 342. A Milky Way twin usually obscured by dust. Euclid's infrared vision pierced through, revealing its spiral arms and star-forming regions. 5. The Horsehead Nebula. Euclid detected free-floating planets FFPS and young stars in the stellar nursery. The Long Bar. A stellar highway. The Vista survey has revealed a prominent feature in our galaxy known as the Long Bar. This elongated structure of stars extends from the central bulge and plays a crucial role in the dynamics of the Milky Way. By analyzing color magnitude diagrams, astronomers have determined that the long bar is inclined at an angle of approximately 41 degrees relative to the line connecting the Sun and the galactic center. Hypervelocity stars, galactic fugitives. Among the myriad discoveries, Vista has identified hypervelocity stars moving at such high speeds that they can escape the gravitational pull of the Milky Way. These stellar sprinters are believed to be ejected by interactions with the supermassive black hole at the galaxy's center, offering insights into the extreme gravitational environments near black holes. Gaia's galactic cartography, mapping the Milky Way in 3D. A billion-star census, the European Space Agency's Gaia mission has revolutionized our understanding of the Milky Way by creating the most precise 3D map of our galaxy to date. Over its operational period, Gaia has cataloged more than 2 billion stars, mapping their positions, motions, and characteristics with unprecedented accuracy. Euclid's Quest, illuminating the dark universe, mapping dark matter and dark energy. Launched in 2023, the Euclid Space Telescope aims to unravel the mysteries of dark matter and dark energy, which together constitute about 95% of the universe's total mass energy content. By observing the shapes and distributions of billions of galaxies, Euclid will create a comprehensive 3D map of the cosmos, shedding light on the large-scale structure of the universe and the influence of dark energy on its expansion. First glimpses, a cosmic panorama. Euclid's initial observations have already yielded stunning images, including a detailed view of the Perseus cluster, revealing over 1,000 galaxies and numerous background galaxies. These early results demonstrate Euclid's capability to peer deep into the universe, capturing the intricate tapestry of cosmic structures. Gaia's upcoming data releases. Although Gaia concluded its observations in January 2025, the mission's legacy continues with forthcoming data releases. Data Release 4, expected in 2026, will provide enhanced astrometric and photometric data. While the final data release 5, anticipated by 2030, will offer the most comprehensive catalog of stellar information, further refining our understanding of the Milky Way. Euclid's continuing exploration over its 6-year mission. Euclid will survey over a third of the sky, capturing images of more than 1.5 billion galaxies. What's next? Gaia's final data releases 2026-2030 will refine our galaxy's 3D map. The universe's 6-year mission will probe dark energy's role in cosmic expansion. Future telescopes like Gaia Near launching 2045 will push even deeper into the infrared. The more we look, the more we realize we've only scratched the surface of the universe's secrets. What hidden discovery excites you the most? Let me know in the comments, and don't forget to subscribe for more cosmic revelations.